Today, we're excited to tell you more about Spocky, our AI agent built for time series data. In this session, you will get an overview of our Spocky capabilities. Then we'll walk you through a live demo comparing Spocky with some of the most popular tools used in the market. And finally, you'll learn how easily Spocky integrates with your existing platforms. The session will take about 20 minutes with time for Q&A at the end. So let's dive in. Spocky was created to help companies move beyond dashboards. Indeed, companies today are more and more efficient at data collection, and storage, while dashboards provide surface-level insights. That being said, dashboards capture a fraction of the existing data, and when it comes to asking deeper questions and querying raw time series data, teams hit roadblocks such as latency, scalability, and reliability. As we said, most companies have already solved the basics, data collection, storage, and dashboards, but things break down when operations or business teams want answers to complex or urgent questions. These queries often require raw data, and that's where traditional setups fall short when it comes to time series data. Indeed, what we see on the market is that answers can take several days from data teams. These data teams are pretty overwhelmed with all the queries they have to manage, while business teams can get pretty frustrated because of the time to answer, but also because they would like to ask more questions most of the time. So that's the main frustration. Data is there, but not being accessible. The business decision process can be pretty blind. It's where Spocky brings like something that is really game-changing with conversational analytics for time series. So no latency, natural language. It's really the way to enable the democratization of raw data query. Maybe a use case that can be interesting regarding failure prevention across industries, something that we see a lot is that companies very often learn about failures when their clients tell them about it. So the goal, obviously, is to detect and resolve these issues before clients notice it and reverse the script. Here's how it works, and our goal was to make things very easy, so Spocky could really enable this. So the step one is to connect Spocky to your raw data, then to ask your question very easily in natural language, and then to get instant visual answers. Could be maps, could be diagrams, text, depending on what's relevant regarding the question. The benefits are pretty straightforward: faster anomaly resolution, better SLA, better customer support, and a path towards predictive maintenance. Another interesting use case is more related to research and development, innovation, where engineers are also limited in queries, still for the same reasons. And the goal is to enable data-driven decision-making process. The examples in the industry are often companies like SpaceX or Waymo that can really innovate much faster than their competitors because engineers have access to more data. We have cool use cases in the aeronautics sector, for example, where we see engineers go from 1 query per week before they implement our technologies to 100 queries per day, which is a significant difference in terms of being data-centric and making decisions based on data. The reason why Spocky is very unique and can accomplish more than most technologies on the market is because we've been working for 12 years on developing a technology suite, mostly open source, dedicated to time series. So 4 main layers. The first one is a time series database, Word10, that allows real-time ingestion. A format, H files, for active archive, meaning like to compress the data and make it quickly accessible. The heart of the technology is an analytic engine with 1,300 functions dedicated to time series. So to synchronize data, to clean data, to manage data holes, to compute KPIs, for example. The last piece is about visualization with discovery that allows dynamic dashboards. Again, we can do all of this, and Spocky can perform because it leverages 12 years of research and development and experience processing time series at a large scale. So now let's get to the demo where Jean-Charles and Mathias are going to show you how Spocky can perform against a bundle of great technologies. And so for the sake of the demo, you will see InfluxDB for the time series database, Cloud for the LLM, and with MCP in the mix.
So yeah, we are going to walk you through the use of Spocky by comparing it with a more traditional approach where you would connect a database, InfluxDB in that example with Claude as the Claude client, sorry, using MCP. And Spocky on the other side, where Spocky has been set up with the exact same data source and using the same model. So both setups are using the same LLM, which is Claude Sonnet version 4. And we are going to walk you through some prompt examples, and we're going to see and explain how the two different approaches actually behave.
Okay, so let's say we are a non-technical person, and we want to fetch data and to visualize it. So here, the first prompt we'll use will be on a narrow time range, and we will just fetch the external temperature of heat pump equipment. So I've inserted the same prompt in both systems. So on the right, we have Spocky, our model, and on the left, we have the baseline, and they both have the exact same prompt. So we can see that on the right, we have already our answer. And on the left, it is still processing, and it stumbles here on an issue, but this is as expected, and we have prepared the follow-up. So Mathias, why did the lab system fail here?
So Claude, as you could see, maybe briefly, was attempting to actually issue a query towards the InfluxDB database to retrieve the data. But based on the prompt that it was actually given, it was lacking some technical details to understand how to actually retrieve that data. So now what it does is that it actually asks the user to provide those details. But unfortunately, in the approach we want to actually tackle, which is to give access to non-technical people to a lot of data, most of the time, the users in front of the terminal, in front of the screen, will not have the actual information that are requested by the model. We're nevertheless going to provide that information. So Jean-Charles, you actually completed the prompt with information, and you're going to run it, right?
Yeah, okay, so that's the first kind of configuration that has to be done, because the hope is that we ask a query in natural language, and the model should be able to understand our query and act accordingly to provide the correct answer. So here we have to precise some information that are related to the schema of the database, whereas on the right, it already understood what it had to explore and retrieve the correct specification to get the right data. So on the left, it finished and successfully retrieved the data, but did not plot it already. So I'll just ask him to plot it now. And as you see, it's the third turn of the conversation. It takes more time, whereas on the right, we had all the answer in only one turn.
And again, if you look at what Claude is doing right now, Claude is actually attempting again to write code to answer and provide the display. So right now it's answering the question that it was asked by generating HTML and JavaScript code. And it finally goes with a result, which is a graph. But if you look carefully, Jean-Charles, why are the graphs different?
Yeah, so the short answer is that one is correct, the Spocky's answer, and the other one is incorrect. And the reason is that here Claude has not any knowledge of time series data, or it doesn't understand the true nature, which here has irregularly spaced out timestamps. So he had to put the data on the x-axis accordingly, which here is not done properly. Whereas Spocky has understood that and I was able to give the right visualization. Plus, it also added some observations. So let's now try a more challenging prompt, because here we were only, as you see, on half an hour. So half an hour is easy for our model, but we will now scale to a more difficult challenge. Okay,
so the goal will be to actually fetch more data from more systems. So instead of actually requesting half an hour of data for a single system, we are going to retrieve, I think it's what, 3 months
yes,
worth of data for 3 systems.
Okay. So here we have asked for data from the 1st of March and the 1st of June, and this time for 3 equipments. And the same query has been given to both models. And okay, we've given exactly the same query, but as we showed on the previous prompt, we could give less technical details to Spocky, and it would have understood it as well. So we have our result on the right. What happens here on the left is that we stumble again upon another issue. So here the model says that the query returns a very large data set that exceeds the display limits. In fact, off the shelf here, the system will not scale, and we've got to wait that he's doing something.
And if you look at the output from Spocky, Spocky says that, so Spocky displays the data and says that it returned roughly 250,000 data points. So on the Spocky side of things, the data was fetched quite fast. And again, you didn't see any query being generated. And on the Claude side, ultimately, it didn't display anything. And it found out that the data was too large to actually fit in its window, and it just gave up.
Yes. Yeah, as we can see here, on the left, the system has sampled the data points, and he's asking that we change our query, whereas on the right, we have all the data points. We can zoom in, and every data point here have been properly plotted. And we can also ask a follow-up to Spocky. But now let's try something more challenging. This time, we'll do something that is more useful than just fetching temperature data. So this time, we'll fetch 6 months of data. We could have asked for a year, for 2 years, for 3 years. We have made it very scalable. And we'll ask this time for performance analysis. So it is starting to think, and it selects to calculate the coefficient of performance. Matthias, why is the COP useful in this use case?
So for heat pumps, the COP, the coefficient of performance, actually gives a ratio. To summarize, it gives a ratio between the amount of energy that the equipment actually has consumed and the amount of heat that the equipment was able to actually provide. So monitoring that coefficient very closely enables people in charge of those systems to understand how they behave, if they're behaving correctly, or if there's an anomaly that might need some action on their part. So again, this seems technical, but for people who are in the business of actually working with heat pumps, it is something which is in their field of understanding, in their skills. So we're not talking about technical details for the underlying operation of Spocky, but really about technical details about the actual business that user is in.
Okay, so in the meantime, Spocky also has memory about the data it is processing. So I asked him to detect some anomalies. And so it has started an analysis. And first, it detected no standard anomalies. And so it then proceed to do a seasonal analysis, because this data is very sensitive to days, to months, and to cycles. So it then proceed with a correct anomaly detection techniques and found this time more anomalies. This information is then presented and summarized, and it's very useful for people that operate this data to then proceed onto an action.
So yeah, you've seen that both in terms of ease of use and performance, Spocky was really on top compared with the other approach. And in the day-to-day operations of some business-oriented people, it might actually be a very helpful assistant to actually make decisions and help them progress and make sure that their equipments are operating correctly. One thing that we didn't mention yet is that in all those operations, the raw data that was actually managed by Spocky never was sent to the LLM, which is not the case with the approach of using Claude with MCP. So the vast amounts of data were handled by Spocky, and then that enabled the LLM to actually provide rapid answers and correct answers to the question that it was asked. We just scratched the surface of what Spocky can do, and right now I'll give the hand back to Nico so he can summarize what we've demonstrated and actually take you further in understanding how you can implement it in your own setup.
Thank you, Matthias. And so maybe, yes, to summarize, there were like 5 main things that you saw that are worth remembering. First, in terms of scalability, we saw that the bundle of TSDB plus LLM and MCP would have limitations of hours of history and thousands of data points, whereas Spocky can process years of history and with no data point limits. In terms of latency, we have 20 data points per second with the bundle, whereas Spocky can perform 5,000 times faster. In terms of accuracy, we saw that the LLM has to create code on the go, lacking context most of the time, while Spocky could really leverage much more context and the 12 years of R&D that we mentioned before. So I think it's a good illustration of how it shows. In terms of ease of use, the LLM required to add a lot of technical wording, whereas Spocky could do a lot of everything in natural language. No technical wording additional was required. And you couldn't see it, but in terms of cost, obviously there's one that is predictable and consistent, that's Spocky, whereas cost can go quickly out of control with the bundle. Last thing maybe is on how to implement Spocky. Our goal is really to focus on the time to value to make it very, very fast. So we have like 3 phases. The first phase is really plug and play. The goal being to just give access Spocky to the raw data and then use the API to ask the questions and get answers the way you saw it. Then the phase 2 is about enhancing Spocky capabilities in order to expand the scope and the relevance. And the last phase is about including business knowledge to get to predictive maintenance and to enable Spocky to be very proactive in many ways.